A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you've just written this incredibly sophisticated AI agent. It can browse the web, reason through complex data, and even call external APIs to get things done. You're ready to ship it, but then the reality of the backend hits you. You realize that if your script takes 10 minutes to run, a standard serverless function is going to time out and die. If your server restarts mid-loop, your agent loses its entire train of thought. Suddenly, instead of building cool AI logic, you're stuck managing Kubernetes clusters, setting up Redis for state management, and staying up at night wondering if your webhooks are actually hitting a live endpoint. It's a massive buzzkill for any developer who just wants to stay in the flow of code.
It really is the infrastructure tax of the agentic era. You start with a Python script and end up as a part-time DevOps engineer just to keep a single conversation alive.
Exactly why we're diving into this today. Daniel sent us a great prompt about this exact struggle. He wrote, "I'm looking for the top 5 platforms for running durable agentic backend workflows. The use case is simple. A developer wants to define an agent workflow in code. No drag and drop builders. But they don't want to manage the infrastructure to keep it persistently available. They need authenticated webhooks to trigger jobs, environment variable management, deep observability, and LLM routing. Basically, a code-defined agentic backend that just works. What are the best options right now, and what are the honest trade-offs?"
Herman Poppleberry here, and I have been waiting for this one. We are in April 2026, and the landscape for what we call durable execution has absolutely exploded in the last few months. It's no longer just about running a script, it's about workflows as code.
And just a quick heads up for everyone listening. Today's episode is actually being powered by Google Gemini 3 Flash, which is fitting since we're talking about the high-tech backbone of the AI world. So, Herman, when Daniel says durable, what are we actually talking about in a technical sense? Why can't I just wrap my agent in a fast API endpoint and call it a day?
Because the A in API usually stands for application, but in the agent world it might as well stand for anxiety. If your agent is doing something complex, like researching a topic for 20 minutes, a standard HTTP connection is going to drop. Most serverless platforms like AWS Lambda have a hard time out, usually around 15 minutes. If your agent is halfway through a multi-step reasoning process and the environment kills the process, all that state, the thought, the agent was having is gone. Durability means the platform checkpoints your code. If the server crashes, the platform resumes the code on a new machine exactly where it left off, with all the local variables intact. It's like a video game save point for your source code.
That sounds like magic, or at least like a lot of very clever engineering under the hood. And it feels like the timing is right, because we've seen major moves lately. Temporal just dropped version 1.25 in March, with native LLM task queues, and even the old guard like AWS Step Functions added specific AI orchestration patterns back in January.
The industry is moving away from simple triggers and toward persistent state. We're moving from a world of stateless requests to a world of stateful agents that might live for days or weeks while they wait for a human to click an approve button or for an API to return a result.
Well, I'm ready to see who's winning this race. We've got 5 heavy hitters to get through, ranging from the developer-favorite startups to the massive cloud providers. Let's get into the meat of it. Where do we start?
We start by defining what a durable agentic backend actually looks like in 2026, because the requirements have shifted. When Daniel talks about a code-defined workload, he's drawing a line in the sand. He doesn't want a no-code box shoveling interface where you drag a send email block to an LLM block. He wants to write a Python function or a TypeScript class, hit deploy, and have that code become a living, breathing process that can survive a server restart.
Right. And it's not just about surviving a restart, it's about the plumbing around the code. If I'm building an agent that needs to, say, monitor a GitHub repo, summarize issues, and then wait for me to approve a draft response, that agent is essentially sleeping for hours at a time. In a traditional backend, I'd have to manage a database to save the state, a queue to handle the retries, and a cron job to wake it up. A durable backend platform says, don't worry about the database or the queue, just write your code. When you call 808, we'll pause the execution, save the entire call stack, and wake it up whenever the data hits our webhook.
The authenticated webhook part is crucial too. You want your agent to be triggered by external events, a Stripe payment, a Slack message, a custom telemetry signal, but you don't want to spend 3 days setting up OAuth or middleware just to verify the payload. You want a platform where you can define an endpoint in your code and have the infrastructure handle the security and environment variables.
And don't forget the observability. If an agent hallucinates or gets stuck in a loop calling an expensive model, you need to see that in the logs immediately, not 3 days later when your credit card gets declined. You need a nested tree of every LLM call, every tool execution, and every decision the agent made.
It's essentially infrastructure as a service, but specifically for the non-deterministic, long-running nature of AI. We're moving from request response to workflow as a service. That's the target Daniel is aiming for.
So we're looking for the sweet spot, the power of writing raw code with the convenience of a managed cloud. Let's look at who's actually delivering that, starting with the platform that's been making a lot of noise lately by pivoting hard into this space.
If we are talking about the gold standard for this, we have to start with Temporal. They've been the heavy hitter in durable execution for years, but the March 26 release of Temporal 1.25 really changed the game for agents. They added native large language model task queues. Before that, you had to sort of shoehorn your AI logic into their standard workflow, activity model, but now it's built to handle the non-deterministic nature of these models.
It's funny because Temporal used to be the thing you only touched if you were building a high-frequency trading platform or a massive payment processor like Stripe. It felt a bit like bringing a tank to a knife fight for a simple chatbot. But now that agents are actually doing multi-step reasoning, that tank is exactly what you need. If your agent is halfway through a research task and the worker crashes, Temporal doesn't just restart the whole thing and bill you for another 10,000 tokens. It knows exactly which line of code it was on and resumes from the last checkpoint.
That's the event sourcing magic. It's not just saving variables to a database, it's recording every single side effect. When the code replays, it doesn't actually rerun the expensive tool calls or the LLM prompts. It looks at the history, sees that the prompt already returned a specific JSON object, and just hands that result to the function. It makes your code look like a standard linear script, even if it takes 3 days to finish.
I saw a case study recently where a developer built a routing agent on Temporal. A webhook from a chat app would trigger the workflow, and the first step was a fast, cheap model to categorize the intent. If it was a complex technical query, it would route to a heavy-duty reasoning model. If it was a billing issue, it would wait for a human-in-the-loop signal from the finance team. The developer basically wrote a while loop with some if statements, and Temporal handled the persistence of that entire decision tree.
And if you want that same reliability, but you're already locked into the Amazon ecosystem, you're looking at AWS Step Functions. They had a massive update in January for AI orchestration patterns. It's a different philosophy because it's fundamentally serverless and state machine based. You get authenticated API gateway triggers out of the box, and everything flows into CloudWatch logs.
But Step Functions feels a bit more like Lego bricks, compared to Temporal's write whatever code you want vibe, right? You're defining states in Amazon states language, which is basically a giant JSON file.
It is, though the CDK support has made it feel more like code lately. The trade-off is the overhead. Temporal gives you ultimate control and local determinism, but the learning curve is steep. You have to be careful not to use things like random number generators inside the workflow logic. Step Functions handles the infrastructure scaling better without you thinking about workers at all, but you lose some of that granular code level flexibility. For an agentic backend, the durability is the feature. You're trading a bit of execution speed for the guarantee that the job will eventually finish, no matter what happens to the underlying hardware.
It's that classic trade-off between the Lego brick, orchestration of AWS, and the pure code approach of Temporal. But if you're already living in the Google ecosystem, Google Cloud Workflows is the middle ground that's been getting a lot of love lately. They had those February enhancements for observability that specifically targeted long-running AI traces.
Google Cloud Workflows is fascinating because it's fundamentally a HTTP-based orchestrator. It's serverless, so you aren't managing workers, but it's remarkably good at LLM routing. You can trigger a workflow via an authenticated webhook through a cloud function, and then it can coordinate calls to Vertex AI or even external APIs. The February update added much better tracing for nested LLM calls, so you can actually see the latency of each thought in the agent's process right in the console.
Is it still that weird YAML-based syntax, or can I stay in my IDE?
It's still mostly defined in YAML or JSON, which is the friction point for a lot of people who want workflows as code. But for multi-cloud flexibility, it's actually a sleeper hit. If you want to trigger a job from a webhook and have it branch out to 3 different model providers based on the initial prompt's complexity, it handles that state management without you needing to stand up a database for the checkpoints.
Now, if we look at the enterprise side, Azure Durable Functions is the one I see mentioned when people are doing heavy-duty.NET or JavaScript work. They had that December update with the AI extensions, right?
They did. Azure Durable Functions is a very mature implementation of the virtual entity pattern. It's great for agentic backends because it uses Azure Key Vault for environment management and application insights for logs by default. The December update specifically made it easier to maintain conversation state across multiple turns in an agentic loop without manually passing a massive JSON object back and forth. You essentially just write a standard function, and Azure pickles the state of your local variables into table storage automatically.
It sounds like the safe choice for a corporate environment. But what about the developer who wants the power of Temporal without the enterprise headache? I know Fly.io has been making moves there.
That's the hybrid approach. You use Fly.io for the compute layer, running your workers in those fast global micro VMs and then point them at a temporal cluster. What's cool is that Fly adjusted their pricing just this month, in April, making it way more cost-effective for small-scale agents. You can run a tiny temporal sidecar and have a durable backend for basically pennies if your agent isn't constantly looping.
So we're seeing a real shift here. We're moving from, how do I keep this server alive, to how do I define the logic of the agent's life? But isn't there a massive second-order effect here with vendor lock-in? If I build my entire agent's brain around Azure Durable Functions or AWS Step Functions, I'm not just moving a script, I'm moving an entire state machine architecture if I ever want to switch.
You're absolutely right. That's the hidden cost. You're offloading the ops work, but you're tethering your logic to the platform's specific way of handling retries and state. If you go the Step Functions route, you're married to the AWS ecosystem. If you go with Google Cloud Workflows, you have more multi-cloud flexibility, but you're writing in a proprietary orchestration language. It's a classic architectural trade-off, speed of delivery versus long-term portability.
It's the Home Depot problem. You go in for a light bulb and walk out with a whole smart home system that only works with one brand of hub. But when the alternative is building your own event sourcing engine from scratch, I think most developers are happy to take the lock-in if it means their agent actually finishes its task.
That's the calculation everyone has to make. But if we distill all this into a decision framework, the first actionable insight is pretty clear. If you need to go from zero to a working prototype by the end of the day, stick to the ecosystem you already inhabit. For most developers, that means starting with AWS Step Functions or Google Cloud Workflows. The setup time is almost non-existent because you aren't managing workers or clusters. You're just defining the state machine and letting the managed service handle the authenticated webhooks and environment variables.
It's the path of least resistance. If I'm already using AWS, spinning up a step function to orchestrate a few Lambda calls for an agent is a no-brainer. I get the logs in CloudWatch for free, and I don't have to explain a new line item on the bill to my boss. But, and this is the second big insight, if you're building something that's actually mission critical, Like an agent that's going to run for 3 weeks and handle sensitive data, you have to look at Temporal. Its durability is the gold standard, and because it's open source, you have that escape hatch, where you can self-host if the cloud costs ever get out of hand.
The durability of Temporal is uniquely robust because it doesn't just retry a function, it reconstructs the entire state of the workflow by replaying the event history. For a complex, long-running agent, that's the difference between a minor hiccup and a total system failure.
So, for the listeners sitting there with a half-finished agentic script, what's the immediate move? I'd say evaluate based on your current stack. Don't over-engineer it on day one. Pick the platform that integrates with your existing log aggregation and identity providers. Set up a sandbox. Test how it handles a webhook trigger when the LLM takes 45 seconds to respond, and see if the observability gives you a clear tree of what the agent actually thought. At each step, if you can't see the trace, you can't debug the agent.
That's the perfect place to leave it. If you can't see the internal monologue of the agent, you're just staring at a black box hoping for the best. And what's wild is how fast this is moving. As of April 26, we're seeing a massive shift toward integrated AI observability. It's not just about, did the function run? It's about, did the agent hallucinate on step 4 of a 12-step chain? We're getting to a point where these platforms might make third-party logging solutions redundant because the tracing is so deeply baked into the execution engine itself.
It makes sense. If the platform is already checkpointing the state, it might as well recorded the prompt and the response too. But it leaves me with a bigger question. Are these platforms always going to be workflow-centric, where we're basically just drawing sophisticated maps for the AI to follow? Or are they going to evolve into something truly autonomous, where the platform itself manages the agency?
That is the frontier. Right now, we're still mostly using these as guardrails, durable tracks for the train to run on. But the more these engines understand the intent of the code through better LLM routing and native task queues, the closer we get to a backend that isn't just a host, but a partner in the execution.
Well, until the backends start writing the podcasts themselves, you're stuck with us. This has been a deep dive into the plumbing of the future. Big thanks to our producer, Hilbert Flumingtop, for keeping our own workflows durable.
And a huge thank you to Modal for providing the GPU credits that power the infrastructure behind this show.
This has been My Weird Prompts. If you found this useful, search for My Weird Prompts on Telegram to get notified the second a new episode drops.
See you in the next one.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth, from man, from long-eared host. My Weird Prompts, until next time, stay curious, keep